Portable Filament Storage Rack by Joshua Rubin and Hunter Now. Over the past couple years, 3D printing has gained a lot in popularity due to the lower cost now. In commercial industries, they use it for printing houses with concrete and also printing rockets and rocket engines with metals. For household use, there is resin and then also plastics. The plastic roll is pictured in the slide here on the spool, which helps hold the material. Currently on the market, there are no small storage rack solutions. There are only larger racks. Racks are not required, but they are helpful since they keep the spools organized and also out of the way of children and pets. And they also can help prevent moisture and dust and dirt buildup, which could damage the spools. So for design, we decided to do allow it to hold up to 12 spools, 6 on each side. It's also portable and it's a do-it-on-your-own project. Most of the designs you see online are vertical, so they can tip easier. We made it so that you could load just one side with just 6 rolls and it won't tip over. It's about 20 inches in length, 16 inches tall. Each peg is about 3.5 inches, and the whole ground support is about 5.5 inches, and that helps add for the factor of safety so it does not tip over. For the material and the specifications, the inner diameter of the spools is about 0.98 inches and 7.99 inches for the outer diameter. Each spool weighs about 1 kilogram or 2.2 pounds. So we chose steel and PVC for the design because they're most readily available and as well as the cost. Each of their actual materials are listed along with their tensile strengths and weights. We also chose a larger diameter for PVC because it's not as strong as steel. So for some assumptions, we decided to calculate it with up to 3 pounds, just in case they were to put like 2 smaller spools on one peg or accidentally buy a larger spool that weighed more. We also designed with the same cross section throughout, so the pegs and the ground supports are all the same. We did not account for the weight and cost of fittings, and since we could not find a shear yield strength for PVC, we calculated by doing 0.58 times the tensile yield strength.
Okay, welcome to the equations page. We've got the normal stress equation here. We got the bending normal stress equation. We got the section modulus of a ring equation. And we got the maximum shearing stress of a circular cross-section equation here. Then moving on, we got the free body diagram of our rack. And we're doing the analysis of the top beam here. We have just the weight of the spools and not the weight of the rack itself because we haven't picked out the material at this point. Draw out the shear force diagram and then the bending moment diagram and get the 120 pounds per inch. From there we can pick the 2 materials and their dimensions. Then we use their weight to redefine this equation, and from there we'll get the maximum shear and the maximum shear in PVC. And then we got the maximum bending moments with the weights added here. And then we got all the results summarized in this page, including the total weights of each one, the stress from the bending moment, the maximum, and then their factors of safety, and the shear stress again from the beam design, and then the maximum with their factor of safety, and finally cost. And then the last page here, we just got our references for the pictures used.